Hi, I'm Dave Winges, and I'm back with a quick update for my binary calculator project. I now have a fully completed assembly on a circuit board, which I demoed in a previous video. I will go through some minor changes I made when I went to the circuit board. I now have a power jack here to take in 9 volts DC, or actually it can go down to 7.5 volts DC because of this voltage regulator, 7805L. Here's my power on and off switch. This is my ISP programming interface. I left that in. This LED is on the SCK line and also on one of the row or column lines pulling the push button switches. That's why it's driven high and illuminated. Here is my reset switch. And here are the 16 push button switches. I have a few logical functions, negate, which is a 2's complement of the result, exclusive or, and. Bottom row here is division, multiplication, subtraction, and addition. Over here I have the operand 2 entries here on these 3 buttons. This is for 0, it's for 1, that's to clear the operand 2 entry. And the same buttons down here for operand 1. This button in the corner is all clear, and this button is a not, which is just a 1's complement. It inverses all the bits in the result. So we'll go through to a quick demo. I will enter for operand 1, 3. For operand 2, I'll enter a 2, and we'll go through all of the functions. So first, we'll do addition. And we get 5 in the result. For subtraction, we should get 1. Multiplication, we should get 6. And then for division, the result winds up being the high byte here is the result, the low byte is the remainder of the calculation for integer math. So here we get 3 divided by 2 is 1 with the remainder of 1. Going through an AND, let me try a reset here and re-enter those numbers. 3 for operand 1. 2 for operand 2, and it's not working. Shoot. There we go. The MCU chip was coming loose from the low profile socket there. So an AND of 2 and 3 gives us 2. An OR gives us a 3. Exclusive OR gives us the 1. And not function, I'll do the 2's complement first. That should give us the negative result. And FF is -1. And as you can see, I don't know if you can see it in the video, but you can see the pulsing on the result LED banks. That's due to the pulsing of each of the displayed banks from the transistors, so they're not all being driven at the same exact time. And going back to the original display, and what happens also when I do the 2's complement of the result, it blanks out the operand displays. So once I do that again, it takes the negative of those And then the not just inverses everything. So that's a quick video of my completed binary calculator project, which, as I mentioned in the earlier video, was programmed in assembly language. And there may be a follow-on video because I'm considering coming up with another version of the circuit board with parts placement a little more centralized to allow easier insertion into some kind of a case setup, and to investigate another circuit board manufacturer in China. This one was from Advanced Circuits in Colorado at 4pcb.com. I'm also looking into doing the board over again, as I mentioned, different parts placement, and going with a different PC board manufacturer, which is far cheaper than Advanced Circuits, but I'm going to want to investigate the quality for that much lower price. Anyway, thank you for viewing, and watch my follow-on videos.